very good day to all of the participants. So I will present my paper, the effect of maltodextrins and Acacia on encapsulations of fixed powder physicochemical properties. So I am Noorsabrina and Salbi, the first author of this paper, together with Noorsabrina and Razin Abdullah, and we are from Physicochemical. As an introduction, pig has been known since ancient times for its phytochemicals that relate to its curative properties, which have been utilized for the treatment of various ailments. The most phytochemical contents of pig is flavonoid, which are quercetin and luteins. As stated by Harvey, pigs can remove the kidney and urinary bladder stones, release intestinal pain, piles, dyspepsia and anorexia. The investigation by Sonia et al. Deals with the nutritional, phytochemical, and oxidant and antibacterial activities of fried pigs, indicates that polyphenols contribute to its high antioxidant activities, which contribute to anti-cancer, anti-inflammation, anti-acne, and antibacterials, also supported by the Mahmoudi et al. So this indicates that the needs of bioactive of pigs to be preserved by encapsulations. Encapsulation is the process in which one material is entrapped or coated with another material in order to protect the coated material against adverse conditions and nutritional deteriorations. The coated one is named as the core or active material, and the surrounding one is called coating materials. In addition to the protection by encapsulation process, controlling the release of core material and masking the undesired properties of core material can be achieved. Coating material have significant roles in stability of encapsulation process. Different kinds of coating materials are used for encapsulation process, such as polysaccharide, proteins, and lipids. Maltodextrin has good solubility in water and low viscosity values even in high concentrations. That's why it's useful for coating materials, and the deficiency of emulsification properties, it had deficient emulsification properties and surface active features, which combining maltodextrin with other coating materials can form a stable capsule. Acacia gum is a composed Acacia gum, but known also as Arabic gum, is composed of branches arrangement of simple sugar like galactose, glucosamic acid, arabinose, rhamnose, and small amounts of covalently bonded protein that give functional properties to Acacia. It has high water solubility and low viscosity than other gum types. Is free of protective films around core materials and act like emulsifier. It prevents aggregation by forming a thick layer. Therefore, this study aims to determine the effects of coating materials, which is maltodextrins and Acacia gum, with different types with different ratio in terms of phytochemicals and chemical properties of the pigs powder form. The control variables is the core to coating material ratio is 1:1. The core, which are the fixed juice, and also coating material, which are the combinations, the 4 different type combination, which is the independent variables. The F1, F2, F3, F4. F1 is 100% maltodextrin, F2 is 100% Acacia gum, F3 is 75% of maltodextrin with 25% of Acacia gum. F4 is 75% or 70% of Acacia gum with 25% of maltodextrins. The dependent variables over the physical properties of the fixed powder and also the chemical properties of the fixed powder is include the moisture, total solid, bulk and type density, Hodge ratio, Karsh index, total flavonoid content, and also antioxidant activity by the percentage of inhibition of ADPH radicals. So for the method of encapsulations, the feed juice preparation, the feed will be prepared first by the juice maker, and the coating material will be prepared first based on the stated formulations, And second, the core and coating materials mature up the pads by the high-speed homogenizer to mix it well between the core, between the fixtures and also the coating materials, and then it's undergo the drying process at 65 degrees Celsius for 24 hours, and the end, the dried mixture will be ground and stored, packed, and the shrink packaging and stored below the -15 to preserve the quality before further analysis is conducted. For the physical analysis, we do moisture content analysis by moisture analyzer. We do total soluble solids by the hand refractometer. We do the density, Cauchy's ratio recipe. We do the Hash ratio and cost index by the calculation. For the chemicals analysis, the total fibrinol contents we are using are equivalent to quantity. The TFC representatives in milligram, quantity equivalents per milligram, and the pH groups. The antioxidant activity are represented by the percent of inhibitions of pH radical. As the results, for the physical properties, the moisture content of the fixed powder range between 4 to 0.7 to 4 to 0.8. The low moisture content of the powder indicates that the samples would have good keeping quality. Moisture content is the amount of water held in a unit volume of bulk powder as a percentage by volume. Fixed powder with 100% of maltodextrin exhibit the lowest moisture content compared to others. As stated by Barbosa Canovas et al., the requirements of moisture content in powder is issued between 4 to 6 because, as mentioned by Higgins, the moisture content above powder above 10% will be prone to help to grow a mold. From the result, we can see that all the formations of coatings materials or ratio of coating materials give the fixed powder between 4 to 6%, as the total solid range between 0.75 to 0.81. It shows that the fixed powder with Acacia gum had higher bit compared to maltodextrin, the gum with more maltodextrins. This may be due to the glucose content, the glucose contents of the Acacia gum itself. Then for the bulk density and the bulk density, the bulk density of fixed powder between 0.29 and 0.45, while the bulk density of fixed powder will be between 0.47 and 0.56. The volume of fixed powders with Acacia gum in bulk density was higher compared to fixed powder with maltodextrin because of the moisture content of fixed powder with Acacia gum was higher than the fixed powder maltodextrin. The density is correlated with the moisture contents of the powder. This is because the interparticle bonding of the Acacia gum is strong. However, in junction, as the water content was higher compared to maltodextrin particles, resulting in high flat density. According to Z et al., with the low particle size, it was able to accommodate more interparticle frictions and has inhibited the low range of density of the fruits powder. It was clear that changes in coating material composition will result in significant change in the powder density, since the density and bulk density of fruit powder depends on combined value between the coating materials. As for the K index and Hash ratio, if I compare with Acacia gum compared, it shows that the curves in the initial shows for the fixed powder with Acacia gum is higher compared with the fixed powder with the maltodextrin However, the values are still below the 1.4. This indicates that there are desirable constituent properties of the powder which correlated to the better flowability characteristic, which helpful for preventing production stoppage at industrial scale. These is particularly important for the industrial. As for the chemical properties results, estimate shows that the FC range between 15 to 58 to 50 to 99 mg, while the pH inhibition will range from 39.54% to 33.18%, which we can see that the powder with Acacia gum shows more TFC and better antioxidant activity, and shows that positive correlation between flavonoid content and antioxidant activity in sweet powder. It shows that different combination of coating material significantly affect the antioxidant activity, and coating material helps to preserve and improve the antioxidant activity of encapsulation of fixed phytochemical, which is the flavonoid, are the main concerns. As for that, pictures which coated with different ratio of maltodextrin and Acacia gum combinations are statistically proven had different moisture, temperature, solid, dark density, bulk density, crust index, and Mohs ratio. Then it affects antioxidant activity significantly. Then from this analysis, from this study, the best formulations established for encapsulation of fixed fluids are 35% of Acacia gum with 25% maltodextrin, which had good physical quality and improved the chemical properties. Encapsulation of food materials with fried, this can be concluded that encapsulation of food material with fried coating materials combination will improve physical and chemical properties of food powder, and this food powder can be utilized in development or production of nutraceuticals or functional food in future. That's all from my presentation.